Okay, so apart from ethylene and respiration rate, another biochemical changes happen in the plant during the ripening is a plasma membrane degradation or plasma membrane metabolism. The changes of on the plasma membrane. Okay, so why this is a quite important enzyme or biochemical process, because the plasma membrane is like a protection layer of the cytoplasm. Okay, is going to function like we call it containment of the cytosol fluid. You can see that some of this condition when you see the WB injuries of the cell. Injuries of the cell means that the cell the cell remain in the intact form, but suddenly you can see the fluid leach out from the cell. For example, you take a ripe banana, you put in the fridge in the frozen part. Then after 5 days, for example, you take out the banana from the frozen part and put on the table. Once the frozen banana thawed in the room temperature, you can see that will be a watery liquid released from that banana. So that is the cytosol solutions, okay, because of the degradation of plasma membrane. So plasma membrane, if you still remember, is the outer part of the cell, okay, and also the organelle also contain the plasma membrane. And then this plasma membrane, they have many functions. The most important is to containment. Apart from that, they have a protein, either the enzyme protein or structural protein, and most of the lipid they are made from the most of the plasma membrane they are made from the lipids. Okay, so lipid they have two things, lipid bilayer. Huh? So lipid bilayer means that hydrophobic hydrophilic interaction. If you still remember about the hydrophobic hydrophilic interaction, uh, for the lipid, I think Prof Tan already mentioned about the TEG, right? Still remember about TEG?
The diacylglycerol,
Yeah,
triacylglycerol.
triacylglycerol. Okay, so TAG will be function as the hydrophobic region. That's why you cannot see the oil going to mix with the fat TAG. But the phospholipid is different. One part of the fatty acid side chain is going to be hydrophilic region, the light water. So that's why the arrangement of the lipids will be bilayer, meaning two layer, right? So the side chains of the phospholipid tadi, you can have many things. For example, you have the glycerol, you can have the acid, you can have the amino acid, you can have the uh, inositol. Okay, so this is an example of the side chain. Either phosphatidylserine, amino acid serine. You can see the serine amino acid here. You can see the phosphatidyl acid, the phosphate group attached with the OH. You can see the phosphatidyl inositol, the phosphate group attached to the sugar molecule. Okay. And then for the inositol itself, you can see there are many types of inositol heat group. This one is a the inositol have three phosphate group for this one. In certain situation, inositol also can have one only phosphatidyl, three phosphate. So one, or you can have two phosphatidyl 3,4 diphosphate, or three phosphatidyl 3,4,5 three phosphate. So this one. So the changes of the one phosphate molecule in this heat group, or the changes on the acidic condition, the changes on the amino acid, what will happen to the phospholipid bilayer? Anybody want to try? Because the phospholipid bilayer, if you still remember the structure, is going to have the dah maghrib kan? It's going to have the charged molecule. So this one is charged. This is a charged molecule. This is the net charge is 0. This one is negatively charged. This one more charging molecule will be there. So the numbers of the numbers and the combination of the heat group ni on the phospholipid bilayer will change the charge molecule. All right. So the nice thing about the protein in our cell is going to have the region, right? If you still remember the protein characteristic. Do you still remember the protein characteristic that you learned?
They are die. They have
Uh,
two charges.
they have two charges, right? Either it's positively charges or negatively charges. And then the changes of the charge on the phospholipid bilayer is going to attract different protein to come and bind. If they are negatively charged, they're going to attract the positively charged protein. If they are positively charged, they're going to attract the negatively charged protein. And then they're going to repel the same charge. So that is the principle of the protein interaction. So just imagine when you change the charge on the plasma membrane, so different enzyme from the cytosol will come and attach to the plasma membrane. If you change to the negatively charged condition, the positively charged protein will go and bind. So most of the enzyme involved in the ripening, they are positively charged. So when you change when you change the plasma membrane into negatively charged, for example, you add more phosphate, you add more negatively charged. So positively charged protein will go and bind to the plasma membrane, and then they start to do the metabolism, start to do the reaction and so on. So if you still remember the concept of the enzyme interaction, they must go and see the substrate. So substrate of the enzyme now in the plasma membrane, because they are making from different phospholipid bilayer. Okay, so the changes on the plasma membrane will change the characteristic of the cell. For example, the nice plasma membrane should be in the fluid form. Fluid means that bendala, it's like flexible. You like this one, so it's not in the rigid form. So when you change the charge of the plasma membrane, different enzyme come and bind to plasma membrane, and they chop the lipids. As a result, the plasma membrane turns from the fluid phase to the solid phase or gel phase. So means that they are not flexible. So when they're not flexible, what will happen to this cytosol inside the plasma membrane? Is it they can contain the cytosol, or cytosol easily leach out from the plasma membrane? What will happen?
It means when the layers broken or what?
When the layers become rigid, it's not flexible as before. When you change
Oh,
the structure of the plasma membrane, okay,
they will have different permeability. I think they
they
will
will have
change the.
different permeability. They will have different phase. I don't have this figure. Okay, they will change to this condition, right? The fluid phase, you can see the phospholipid bilayer is quite flexible, because they have flexible means that it's like you have the, what you call, if you have the pool ataupun the mattress with the water inside. So when you punch the mattress, it can absorb, and then when you release the punch, your hand, it's come back to original shape. So this is the fluid phase. But in the gel phase is different. Gel phase like you do you do agar-agar, or you do what you call jelly food, right? Okay, you can see there will be a very hard structures on the gel. So that's why in that condition, the phospholipid bilayer cannot function to contain the vacuole solution, the cytosol solution. So as a result, the cell will be ruptured, and then all the liquid inside the cytosol will be leached out. So that situation, right? So who control the phospholipid bilayer degradation, the changes on phospholipid bilayer and so on, is controlled by who? So the enzyme that control this one, they call as phospholipase. Okay, phospholipase is the enzyme that chop down all the fatty acid or the phosphate group, or in the phospholipid bilayer, they have phospholipase A, they has phospholipase C and phospholipase D. So then the name is different. Why the name is different? Because each enzyme, they will chop at different position of phospholipid. For example, this is a TEG, all right, TEG. This is a glycerol bond with different fatty acid, 1, 2, and the third one will be phosphate group, okay, because it's phospholipid. Phospholipase A will hydrolyze in this region. So you're going to produce lysophospholipid. Lyso means that only one fatty acid on the phospholipid. Phospholipase C will hydrolyze in this one. So you're going to remove the phosphate group. It's going to produce the OH, which is very acidic condition. Okay, if they produce OH acidic condition, the enzyme who like the acidic condition will go and bind to the plasma membrane. But those who don't like acidic condition will repel out from plasma membrane. So they're going to change the structure of plasma membrane. Phospholipase D is going to chop and disposition. Is going to produce the phosphatidic acid. Is going to produce another acidic condition as well. Okay. So how to change this? How to control this one? Is by control the enzyme activity, phospholipase D or phospholipase A or phospholipase C. Okay, this is example what happened when you have the ethylene. So ethylene will have the gene expression, it has the phospholipase D, and this is the complete pathway, how it will be gel phase formation, and then it will trigger more ethylene to get generated in the cell. So you can see here there is interaction between ethylene and this enzyme, right? So we take a break.